All right, so polynomials quiz. You know by your remainder theorem, so a good thing to remember, because you may need to think about it, is polynomial, if we divide by a divisor, we get a quotient and plus a remainder there. If it's a factor that we're dividing by, there will be 0 as the remainder. So here we're dividing this polynomial 2x cubed by x plus 3, which means when we sub in minus 3, which is the root, if x plus 3 is the factor, x equals minus 3 is the root. So p of minus 3 gives us whatever remainder we get. So let's have a look. So we put 2 lots of minus 3 cubes, because that's the polynomial. Minus 3 cubed is minus 27, times 2 is minus 54, which is one of the answers. Which one is not a polynomial? So they don't let them trick you with the coefficients. So root 3 is just the coefficient, root 5 is the coefficient, that's fine. We cannot have this one because it's x to the negative 2. So no negative powers, only integer powers as well. So that one is definitely not allowed. All right, number 3. The solution to this equation. So here you can see if I just times the x parts, that x times, and there's a positive x, I'm getting, and it's cubed and squared, etc. It's going to be a positive, so it's happy on its ends, so it's a happy polynomial. And the other thing to look for is the power. So I've got a 3, a 2, and a 1, 3, 4, 5, 6. So it's power of 6. So I know it's going to end with its arms up. It's going to be a happy polynomial, very happy polynomial. All right, so let's have a look. Now we know that 0, this one gives us a root of 0. 0 is a single root. This one gives us a root of 2. So 2 is a double root because it's power of 2. And this one gives us a root of minus 3. And that is a triple root. So it's going to look like a cubic. So if I start up here, this is a double root. Double root is a bounce. Then this is a single root, so it goes through. And then this is a cubic root, triple root. So it's going to look like that-ish, kind of. It doesn't matter. This is just the working, so it doesn't have to be neat. So where is this less than 0? So where is it underneath the curve? Between negative 3 and 0. So it must be A. All right, next question. Okay, so here's a polynomial. It's divided by that much. The remainder is. All right, so here's our polynomial. And so we've learnt different methods, but for example, we could just write this a few times. You might not know how many you need, so you can just keep going or write them when you need to. I might need to just move a little bit this way. Alright, so let's think about this. I want 2x to the power of 4, so I'm going to have to times this by 2x squared. That gives me 2x to the power of 4. But the second term it gives me is, if I look at this, it gives me a negative 6x cubed. Negative 6x cubed. So if I have a look, there are no x cubes in here. So I want to add 6x cubed to balance that, because there are 0 cubes there. So I'm going to add 6x to make that 6x cubed. So that's my first term. There we go. So I've got my negative 6x cubed plus 6x cubed. Now it also, from this beginning one, gave me the next thing I'm interested in is the squares, and I want negative 3x squared. So at the moment I've got 2x squared, and this will give me a negative 18x squared. I've got a 2x squared, negative 18x squared, and what do I want? I want a negative 3x squared. So I'm going to have to add, so that's negative 16. So I'm going to have to add 13x squared. So 13x squared, which is great. That's so that should now give me this minus 3x squared here. Hopefully, if I've done it right. So What else do I have here? Xy's. If I now look at my extra term for this one first, I've got a 6x. In this one, I've got, so if you want me to write, I'll write it over here. I've got a 6x. In this one, I've got a negative 39x. And what do I want? I want just a negative x. Goodness. So I'm going to have to add to that 32, because that's right, isn't it? If I add 32 x's, yeah. So I'm missing now, this is starting with an x squared, so this must be my remainder. I'm going to have to add a 32x to get that. And let's just check, the other thing I've checked is my constant. So the only constant I'm getting is here. This is 13, but I want a plus 4, so I'm going to have to subtract 9. So this part should be my remainder. Sorry, that wasn't very neat. So you can do it that way, or you can do a polynomial division like that, whichever way you like, whichever way you're comfortable with. All right, so going over to question 5. For 5, we know x plus 1 is a factor. Remember, if it's a factor, that means, in this case, x equals negative 1 is a root. So when you sub negative 1 in, you should get 0. Okay, so let's sub negative 1 in. So we'll get negative 1 cubed is a negative 1. Negative 1 squared is 1 times minus 2 is minus 2. Negative 1 times a negative is positive k there, plus 5, and that has to equal 0. So that's minus 3, so that's 2, so k must equal negative 2. That is a C. All right, number 6. So both x minus 1 and x plus 3 are factors, so that means both 1 and minus 3 are roots of this polynomial. So when I put p of 1 in, I should get 0. And when I put p of negative 3 in, I should also get 0. All right, so let's put p of 1 in. So we get 1 minus 4 plus a plus b, and that should equal 0. All right, and if I simplify that, I get a plus b minus 3, so 3 equals 3. Now, a bit harder, but minus 3, so we'll get minus 3 cubed is minus 27. Squared, 9 fours are 36, so we get minus 36. Minus 3a's plus b, and we know that has to equal 0. So again, if I keep that minus 3a plus b, but put everything else on the other side, I'm going to get a positive 30, 40, 50, 62, 63. So I can solve simultaneously. I might actually take this one and subtract this one. Well, it doesn't really matter which way you do it, of course, but I just like 63 take away 3, so looking for something easy. B take away b is 0. I'm obviously working from right to left. Minus 3a take away a, minus 4a. Divide by negative 4, and we will get, that would be a negative 15. And then if I put negative 15 in here, I need to add 15 plus a 3 to get a 3, so I need to add 18. So I'm going to get a equals minus 15, b equals 18. Which one's that one? Negative 15. Yeah, so that's a. Great. All right, number 7. For number 7, we've got, I'll just move it a little bit. We know 3 zeros, so we know the roots are minus 2, 3, and a, and we're asked to find the value of a. Is that right? Yeah, the value of a. Okay, so we don't want too many unknowns because I think I'll have to use simultaneous equations. Anyway, you can play around. But let's say the sum of roots. Sum of roots is negative b on a, so negative 16 on p. So a would be negative 16 on p, and then we've got plus 1 minus 1. All right, what about the product? Because I don't really want this q. I don't want another unknown, so I'm going to use the product. Product of roots, minus 2 times 3 times a. That's the product. So negative b, c, negative d. So negative d on a would be negative 120 on p. So that will give me, I might make p the subject and sub it into here. So p would be 120 divided by minus 6a. So we've got a negative 20 on A. 20 on A, is that right? So if I sub that in, running out of room, for P, then I've got A, I'm using this one, but subbing in this. Excellent working here, not. So minus 16, why don't I times by 1 on P, which means just tipping this upside down. So I'm going to times by negative A on 20, so it's going to be positive. So it's going to be positive divided by 4s, 4 A's on 5s minus 1s. All right, and then what would I do next? I would just go, there's 4/5 A's, and this is 1A, so 1 take away 4/5 is 1/5, so I've got 1/5 A equal, you can do it much better with a calculator, I'm sure. So A equals minus 5, and thankfully there is a minus 5 there. Then I have more confidence that I'm right. All right, number 8. Two roots are reciprocals of each other. Find the value of P. Okay, so it would just take note, it is a cubic. So if they said two roots are reciprocal, I'd say let the roots be alpha, 1 on alpha, and it's got to have a third root because it's cubed, so beta. And then I might do all the addition, etc., etc. So, all right, so if I do everything starting with the addition, so if I add alpha, so if I add the roots, let's add the roots first. I get negative B on A, so that would be negative 1 on 2. I don't know if I'll need that one. All right, if I do the pairs, so I put alpha and 1 on alpha together, that's just 1. And then I'll have alpha with beta, and then I'll have beta with 1 on alpha. So the pairs need B on A would be C on A, which is negative P on 2. Okay, and what else do I have? The product. So the product would be alpha times 1 on alpha, again that's 1, times beta would be beta. Alright, so the product will just be beta. If we times them all by that, we just get beta. So we've got negative B on A, C on A, negative D on A, which is negative 6 on 2. So negative 6 on 2 is 3. So if I go ahead and put 3 in all of these, in the other two, so I've got alpha plus 1 on alpha, minus 3 equals minus a half. And I've also got here this one, I've got 1 plus minus 1 minus 3 alpha minus 3 on alpha equals negative P on 2. And you can see I'm going to get here if I factorize by negative 3, I'm going to get alpha plus 1 on alpha. Now that's handy because from this one up here, I've got alpha plus 1 on alpha. If I add 3, so if I add 3, I'm going to get 2.5 on that side. So actually, if I sub in 2.5, I'm going to have 1 minus 3 lots of 2.5s, which is 5 on 2s. Again, with a calculator might be easier. And that's minus P on 2. So I'm going to get 1 minus 15 on 2. So 2 on 2. Take away 15 on 2 is negative P on 2. Well, they're all on 2. So 2 take away 15 is minus 13. So minus 13 is minus P. So P must be positive 13. I'm going A. Hopefully that's correct. Alrighty. I don't think that's the end yet. So that was using all the sum of pairs, sum of singles, sum of pairs, and the product. And it just helps to be able to manipulate or see patterns and manipulate your algebraically. So practice that. Here we've got alpha, beta, gamma are all roots of this cubic polynomial. Then what is the value of this? So again, hopefully you've seen these before. Add them whenever you haven't. So if I make a common denominator, which would be alpha, beta, gamma. The first one is missing gamma. The second one is missing alpha. The last one is missing beta. So it's just the sum on the product. Now the sum is negative b on a, which is 3 on 2. And the product, negative b on a, c on a, negative d on a, which is 5 on 2. They're both on 2, so it's 3 on 5. So C. And the next one, same. If I have a look, the common denominator would be alpha, beta, gamma, delta. And now you can see what's missing on or what I need on the top. The first one is beta, gamma, delta. And the second one is alpha, gamma, delta. So it's the sum. I'm not going to bother to write it. It's basically the sum of the triples at the top divided by the product. So if you think of that, sum of singles is negative b on a, all on a. A is 1 here, so I don't care about a. So negative b on a. C on a is doubles. Negative, what did I say? B, C, D. Negative d is what I want for triples, and for quadruples, which is product, I want E. So what are those? Negative d. Just be careful here, there's no x squared. So B is negative 3, C is 0, D is 1, and E is minus 7. So we're going to get negative 1 on minus 7, which is 1/7. So A will be my answer for that one. Hopefully that helped.